Ladies and gentlemen, welcome to today's webinar, and thank you for tuning in. Welcome especially to all those loyal viewers who have joined us already multiple times this week. So we all have a relatively fair understanding what AI or big data applications can do for our businesses. But how do you actually implement those projects and processes in your organization? I'm very happy to have Professor Ivo Blohm with me today. Ivo is Professor for Data Science at our university. He will also tell us what pizza and data have in common. Now I would like to welcome Ivo. Thank you for taking the time. I wish you an insightful lunch break.
Hello, my name is Ivo Blohm. I will guide you through this webinar today. Let me start the presentation. And big data and AI are currently a very hot topic, and the hotness of this topic has been best coined by a quote by Dan O'Reilly, who's a social scientist at Duke University, and he said that big data is like teenage sex. Everyone talks about it, no one really knows how to do it, everyone thinks everyone else is doing it, so everyone claims they are doing it. Of course, this quote is a bit exaggerated, but it has a very true core. And as Friederike already said, in this webinar, I will show you, or this is my central goal for this webinar, that you understand what building a data-driven organization has in common with baking bread, baking pizza. So I will run through three areas. First, I want to highlight some potentials of big data and AI, showing some use cases, maybe accelerating what they can mean for your organization. Then I will turn towards the data-driven organization, what it's about, how to build one. And finally, I will share some lessons learned from some head of analytics we had a workshop last week with, and from our work at the university. So if you have any questions regarding one of these topics or something related, just use the Q&A section and drop your questions there. We will discuss that afterwards. My prime example for explaining what big data and AI is about and what potential they can bring for organizations is Oxmoney. Oxmoney is a peer-to-peer crowd lending platform, and if you need some money, maybe for moving house or buying a car, you can make a credit request on that platform, and the other registered users of that platform then can invest in your project. Maybe you invest 100 euros, 200 euros or something like that. And once the project is funded, you get the money and pay back, and then pay back the credit in a defined time frame with a defined interest rate. And for that business model to work, it's essential that the people who want credits get some sort of credit worthiness check, and so that the default risk is estimated. Otherwise, the people won't get back their money and the entire thing will fail. And underneath the surface, Oxmoney is a complete big data player. And they have an algorithm in place where that scores you regarding your credit risk. They buy some more traditional credit risk data like FICO scores or the German equivalent Schufa. They track a lot of behavioral data when you apply for the credit at night or at daytimes. They check your bank account, what are you spending your money for, what are your regular incomes, what are your expenses, and so forth. And if you, for example, apply at night for credit, you get a worse credit rating because otherwise you would have a real job or this assumption which enables you to pay back the loan and you wouldn't request your credit at night. And doing that, they have about a couple of hundred of data points which are used for scoring, and this algorithm then can make really quick decisions. So the credit worthiness of the applicants can be checked more or less in real time and not a couple of hours or business days as in traditional banks. You can potentially make better decisions. Oxmoney is operating in a so-called subprime segment, and the target customers are people that don't have access to traditional credits because they're self-employed or so-called bad risk due to other reasons. And in this subprime segment, Oxmoney manages to predict whether a certain individual can pay back the loan or not with an accuracy of over 89%. The entire process is completely automated, so there's no human involved. works everything by the machine, and it was an innovative way of offering credits when it was introduced. And from my point of view, it always boils down to 4 of these potentials: being faster, being better, being cheaper, or being more innovative. And you can apply that typology of benefits to almost every project. Research has also shown that advanced business analytics leaders, maybe the 8 to 10% of organizations that excel in analytics, are significantly more successful, productive, or customer-oriented. If you speak with colleagues from the MIT, we say, okay, it's about 6 to 8%. If you look at the various reports of the consultancies, it's frequently more than 100%. Of course, the scale varies, but the message is pretty clear. It really pays off. And sparked by such examples, many organizations, potentially also yours, have kicked off so-called pilot projects. I've just taken a couple of examples that I like. Personally, first, the city of St. Gallen, or more specifically, its social security insurance, SVA, has integrated a chatbot with which people of St. Gallen can discuss questions. And from the city of St. Gallen, this is a really prime example for using chatbots, because maybe their clients always have the same 10 to 20 questions, and this can be automated in a very nice fashion, such that they can get responses to their questions 24/7. Another really nice example is the German cutlery and household appliance producer WMF. And I don't know how you take it, but the first thing I do when I go to office in the morning is grabbing a cup of coffee. And in order to prevent upsetting people like me in the morning, they have introduced some kind of predictive maintenance for their coffee machines, for the big ones that are standing in commercial buildings or in other B2B settings. And they use sensor data that is collected in the coffee machines. They use external data of water quality, weather, social media, and then they can predict when a coffee machine is going to fail and schedule their maintenance operations according to these predictions. A final nice example is AXA, or the Swiss unit of AXA Insurance. They have used predictive analytics in their HR department. Based on existing research, they have calculated the probability of how likely it is that their defined job profiles and roles are going to be automated away in the upcoming years. And when they asked their employees where they want to develop into, what their education was, what projects they worked on, and so on, and then they developed some kind of Tinder algorithm that matched these people, those jobs are at risk, to new projects, new job profiles, and so on. And it was a really nice application of that. All these pilot projects have 2 things in common. The first one is that all organizations play them in some sort of their digital transformation journey. Most organizations usually start with some kind of internal perspective, focusing at their internal processes, developing digital processes. For example, the WMF case is in that domain for better scheduling their predictive maintenance operations, or the AXA case is also in this domain. Then you can play that in some sort of outcome perspective, building smart products and services. For example, if you look at Auxmoney, the credit scoring algorithm is at the very heart of the entire business model, and you can't run this business without that algorithm, because otherwise it won't play out. Finally, if you look at the city of St. Gallen and the chatbot example, you can create completely new approaches for interacting with your customers. It doesn't mean that you have to excel in all 3 dimensions if you want to make your organization data-driven or digital, but we should rather be considered as avenues or pathways for pushing that topic forward in order to make a digital company that runs a digital business. The second thing that all pilot projects, or many pilot projects, have in common is that many of them remain pilot projects. The reasons for that are manifold. Sometimes the organizations fail at imagining how AI and big data could help them in improving the operations, so that they don't have any good business cases. Sometimes it's rather a technology-driven topic that organizations put in place some Hadoop or Spark cluster and then wait until the use cases pop out of nowhere like mushrooms. Of course, this usually don't happen. Sometimes it's a problem that the organizations fail to scale their prototypes up. They have really nice use cases, and everything works out place, but then they begin to struggle with defining operating models, setting up the infrastructure and similar topics. And finally, they have issues with change management. Many people or many individuals in organizations don't understand how predictions are made, how the algorithms work, and similar things, so they lack trust. And if you don't have trust into something, the natural reaction is not like, give me more of that. It's rather, well, a bit objective. Okay, I don't trust it. Let's wait a bit and let's see how to play it. And for building a data-driven organization, it's quite important that you understand that scaling up big data in the AI is like a three-stage process. The first one is rather explorative. It's very creative. You have to think out about interesting use cases for your organization. You have to validate them. You have to be quite agile, then prototyping them, and then validating whether it really plays out and it's feasible or not. If so, you have a second phase of technical production. This is completely different. This is very standardized. You have defined processes for developing software, for testing it, for releasing it, and your prototypes must somehow fit into that structure. This is usually a lot of setting up the infrastructure or defining operations, who is going accountable for such a model, who is responsible for that, and defining such things. And finally, you have to have some phase of organizational integration. You have to engage in change management. Maybe you have to redesign business processes and decision-making processes. And after then, you have a good chance that your prototype is used in a regular fashion. So let's make a small poll. Up to you. Which of these phases is make or break in implementing big data and AI? So the poll has just started. The first responses are dropping in. And so far, it seems to be some kind of clear picture. Organizational integration is heading. The other one maybe at the same pace. And I think this is a pretty clear picture. Organizational integration, also from my point of view, is the most important part. If you want to take business analytics or big data and AI seriously, you have to seriously engage in redesigning your business processes. Business process redesign is very 90s. Many consulting agencies earned a lot of money in the 90s with introducing digital processes for the first time. But now, if you want to benefit from AI and big data, there's a new wave of business process redesign to come. You can also back this data. I close the poll. There was a very nice survey by McKinsey that surveyed 1,000 C-level executives of multinational organizations, and they asked them, okay, how much of your IT budget do you spend on analytics? And the top 10% companies, these advanced business analytics leaders, invested about a quarter, 25% into their analytics. The average of all companies was 5%. But the figure what is really more important, more interesting, is the second one. Of those business analytics leaders, more than 50% of these companies invested 90% of their budget for analytics into the last phase of organization integration. And the average across all organizations was only 23%. So organization integration is for sure the most important part here. Before digging deeper into how to build data-driven organizations and to understand where the real problem behind that and what it has in common with baking pizza or bread, you have to first lay out some conceptual foundations and definitions such that we understand that these talk about the same thing. Most organizations I know, and probably also your organization, have been doing business intelligence for decades now. This is building data warehouses, creating reports. In this report, you find figures about which product sold how much in which region. And this is common sense, and this is what you find in your organization. Big data, from my point of view, is rather a technology topic, how to build analytical infrastructures that enable you collecting, processing, and storing big and unstructured data. Unstructured data refers to images, text, log data, and similar things. Machine learning is then developing and applying algorithms for finding patterns in data. And once you have found such patterns, you can use them for making predictions, making recommendations, or whatever you like. Data science is then the process of applying machine learning for improving decision-making or solving problems. And artificial intelligence is then creating intelligent systems that can perform knowledge tasks in a performance that is comparable to humans or even better. AI is a quite old research field. This has been originated in the 50s. There have been many different approaches for doing that, but so far machine learning has been the only viable approach. And the interesting thing is, why is it happening now? There's one quite easy answer to that. It's computer games and cat pictures. So in the 90s, a lot of 3D computer games like Counter-Strike developed, or for rendering these 3D environments, you needed processors and graphical processing units that can render these worlds. And the core to that is matrix multiplication. And if you look at deep neural networks, how they work, they are basically matrix multiplication. So we had a lot of, well, accelerated computing power behind that. Besides, the internet has enabled us to collect huge data sets with thousands or hundreds and thousands or even million pictures, such that we can train such algorithms to detect things like cats in these algorithms. Sometimes you may also find the term advanced business analytics. This is basically everything beyond business intelligence and some kind of surrogate for all these other terms. Important thing is also how to apply analytics in actions, and this slide is pretty crucial. For example, if you want to bake a pizza, you need some kind of ingredients like flour, salami, mushrooms, cheese, and so forth. And this basically refers to the data you need for building some kind of algorithm. The algorithm itself then refers more or less to some kind of appliance, for example, an oven with which you bake your pizza. Then you have a recipe that tells you how to combine your ingredients. The equivalent would be the statistical model that saves and tells you how to combine the different data in order to make predictions. This would be some kind of equivalent of a dish. The dish or the prediction doesn't serve anything. If you're starving and sitting in front of a pizza, your mood won't change and you won't have all the value of eating the pizza. And it's pretty much the same if you don't apply your machine learning results or data science results in organizations, they're not able to create any value for that. And why it is difficult to build data-driven organizations? This could be best explained with some sort of thought experiment. Please imagine you would employ a baker to construct an oven and an engineer to break a bed. And everyone of you knows this won't work out. So maybe the engineer can bake a decent bread, but the baker wouldn't be able to construct an oven. But this is the thing that many organizations do if they refer to data-driven organizations. For example, if you consider companies like Google, analytics, data, algorithms are so core to their business model that they really engage in developing new approaches, new algorithms, and then apply them to their business. If you're rather a company like WMF, the core of your business is building household appliances, coffee machines, producing cutlery, and data science or machine learning can be a tool for doing that. So the goal here is rather to look what there is available, apply that to our context, so-called developing an innovative recipe, and then developing innovative usage scenario for this data. And most organizations fail because they think, okay, we're becoming data-driven, we have to become the Google of our domain, but this is a complete different domain they're compelling at. And the second drawback that can be made from this small thought experiment is that data-driven organizations or these business analytics leaders have built up industrialized bakeries for baking analytics bread, for building prototypes and scaling them. How does the analytics bakery look like? We have here the St. Gallen House of Digital Business. This is some kind of holistic framework that we usually use for explaining digital business and how to transform its organization. It usually starts from being customer-centric and creating solutions that provide customer value. And for building a data-driven organization, you have to integrate the operations with such kind of framework or your entire operations. It usually starts with some kind of data strategy that you have to develop. Where do you want to go? What is the role of analytics in our organization? It has to be aligned with the corporate strategy, maybe with the IT strategy. Then you have to build analytics processes, some kind of data analytics organization. There's a lot of debate in practice right now whether we should build some decentralized analytics units in the business domains like marketing, HR, or it's rather better to go with some kind of centralized center of excellence. You have to look at the technology stack. You have screen and select technologies that help you in integrating your analytics endeavor. This is quite intimidating even for people like me who are very deep in the domain. It's like that every day some new solution pops out and that has some specific benefits. And finally, you have to integrate that into your final system. You have a lot of management tasks that go along with that. You have to engage in change management endeavors. You have things like staff development and recruiting. And there was some very well-published article a couple of years ago that coined data scientists to be the sexiest job of the 21st century. So every organization I meet, I ask, do you have really problems finding data scientists? There's usually one clear result, but maybe this is time for making a short poll. How is it in your organization? Have you problems finding data scientists or not? So the poll has started. So, and most of your organizations says it's indeed a problem. It's followed by organizations that for this is like so-so, and most organizations have no problems finding data scientists. If I speak with head of analytics, the answer is usually very binary. Sometimes it's no, we have no problem at all. We have interesting data assets every data scientist wants to work with, so we can't stop getting applications. And the other one says it's almost impossible for us. We are a second-tier company in our organization. The best data scientists go to companies like BMW or like Google or something like that. But for us, being an OEM or something like that, it's almost impossible to attract talent. So let's close the poll. And finally, you maybe have to think about new compensation models, how to incentivize data-driven decision-making and things like that. Oh, I have to. Then you have to find approaches that enable you to translate your business problems to analytical questions. For example, if you speak to people from the retail domain, they say, okay, what can AI bring for you? They say, okay, we want more leads, we want more conversion rate, we want higher profits and things like that. But these aren't questions you can't model right now. So you have to translate that into some analytical problem, into some kind of question that can be solved by an algorithm. And this is not always easy, but you have to cope with that if you want to build a data-driven organization. When you have to deal with all the domain that I call data defense, you have to manage data governance, you have to manage data privacy, you have security concerns, but maybe to answer this, and if you're, for example, a bank or another financial institution, you may have very strict legal regulations you have to comply with. And finally, managing data quality is a huge problem for most companies I know, because data is always kind of messy, and before building an algorithm, you have a lot of effort to invest until you can start. Then you have, as already mentioned, to define different processes for being in some kind of explorative mode, for building agile prototypes, for building use cases and proof of concepts. Then you have to define product or processes that help you develop standardized processes and approaches for scaling that up. And finally, you maybe have to touch a product and develop new service or new services until you can deliver it to your customers. So there are a lot of questions to be answered here. So that's a quite complex endeavor. Another thing that have been found in practice to be highly important are people like analytics translators. Usually if you have the data scientist units, you have computer scientists there or statisticians, and they are very specific, they have very specific knowledge about how to build a predictive model or something like that. But these people usually lack in-depth knowledge about the customers, about the marketing, about the production discipline, and frequently they have problems to working out what do we really need, what is the prediction target, what should we exactly do in order to reach our business goals. And so you need people that have this deep domain knowledge and can translate that into a language data scientists, machine learning engineers can easily understand, such that they can start building a model. And once this model is in place, these analytics translators can help propagating the model and integrating that in the organization, explaining the value of it in the language of the marketeers or the production planners or whatever the domain is. Last week, we had a really nice workshop in our competence center data-driven organization, and we asked head of analytics, okay, given you have no budget constraints, given you have all the power you need for doing so, what would be the measure, what you would change in your organization for making your organization more data-driven? And results can be clustered into 4 building blocks, more or less. The first one is situated in the structure and processes domain, and almost all head of analytics said, okay, our organization is actually lacking some kind of digital target operating model. We don't know what the journey of digital transformation is heading to, and so it's quite difficult for us to aligning our endeavors here. Some were also complaining that the data science units are rather some kind of virtual organizations that have a set of 2-3 core data scientists, and then they have domain experts regarding the use case that is being developed. And if something changes in the daily business, these domain experts are taken away, and so the entire project is frequently on hold then. And so they would wish to have some kind of overarching organization with a couple of analytics translators that part of a team and cannot taken away if the daily business changes. Finally, our second, it's in the product and service domain. Also here, developing cross-functional teams of data scientists and domain experts was mentioned. And also that major problem referring to data defense is that each organizational unit owns usually its own data, and it's very hard for most organizations integrating that data, merging it, and there's a lot of political discussion around that. Everyone has to be afraid of losing power, losing control, and so there should be some overarching initiatives that facilitates that project. Then there are a lot of management tasks involved. Almost all head of analytics mentioned that they had a really hard job in working around the influences in the management. It was not so much about the top management. They were quite open in embracing the topic. The problem was rather in the middle management, with people working 25 years sometimes in their positions and their reluctance to change. Again, they had fear of losing power and control. And so this was the main roadblocks in the journey of these organizations. Recruiting, education is a topic. How do we find the right people? How do we educate our own ones maybe, such that they can make an analytics role? And all of them mentioned that they are currently working on incentives that translates the data strategy into individual incentives for the people involved in the different businesses. And finally, it's about use, and utility. And here it was some kind of mindset shift what was acknowledged, that every employee has to be aware that you can make things data-driven, that they are able to develop an understanding for what can it mean in my domain and how to proceed and which kind of data I need as a resource for doing so. Finally, also I can share some lessons learned in the manifold projects we did in the last year. And I think maybe the most important one is to be agile in the entire project. At the beginning, if you start with some kind of project, it's new to everyone, and many people and stakeholders involved have no clear understanding what big data and AI is, what they can do with that, how that fits into their operations. And once the project has started, they start to elaborate on and reflect on what has been happening, and then suddenly they understand what they're doing, and then they get a lot of new requirements. Actually, we want to do this or we need that. And so you have to be quite agile in the entire process such that you can accommodate with all these sudden changes when you start in such a data-driven business endeavor. Second, you have to invest, also, as already mentioned, a lot in business process redesign. And my personal experience is that making something better is not enough. If you can predict more accurately credit default rates or which customer is a hot lead or not, it won't bring that much value to your organization, because the natural reaction of most employees involved is, so I'm working to my limits, I'm already quite full, and now I'm asked to go through that report every month or every week, and this is a lot of more work. So you have to think of how you can simplify the working routines for these people using big data and AI. Otherwise, you have a quite high chance that your endeavor will die. And finally, you have invest a lot into change management. You have to take care of all stakeholders. You have to inform them what is going to happen. Most importantly, you have to explain and train them that they can understand what is going to be done. And finally, you have to create trust that they work into results. And there was a very nice example. Yesterday, I spoke with a fintech startup in the insurance domain, and they said, okay, we had a really good intern, and the intern developed a really good predictive model about how we should adapt our prices to our customers, such that each customer gets an individual personalized price. And the model worked really well. But the head of actuary services didn't understand how the model works. And so he said, okay, I cannot approve that because I just don't understand it. I don't trust it. And so there was some kind of, challenge here on how to resolve that. And the interesting thing is that that organization then decided that the model of the intern, who has maybe tenths of the salary of the head of actuary services, is better than the traditional operations. And so this shows very nicely how analytics can change the organization. So that was it from my part. So let's see whether there are any questions.
And screen sharing. Thank you so much, Ivo. Few questions have come in already. Please send us more questions. Please use the Q&A field and not the chat, otherwise I won't receive them here on this iPad. And also you can vote for those questions you find most interesting or relevant. Ivo, could you elaborate a bit more on the translation of data strategy into incentives? How do you do this? What would those kinds of incentives be?
Well, yeah, this is a very crucial topic, and I think it's a quite challenging one. The traditional status quo is that most organizations will face their decisions on the person who has the highest salary check, and they have usually a good intuition about their business, and they're very reluctant to change their opinion. But if you would set incentives for making decisions data-driven, for using data, maybe the situation change such that they rely more on the data. Other things would be if you go to the team level or something, that you focus on how to change your business operations in a data-driven manner, and then give some team bonus or something like that.
Thank you. Could you possibly provide some more details from the third pilot project from Axon, for example? What is the solution like? I imagine HR is a typical field of application for AI.
Well, HR analytics is one of the hottest fields in the analytics domain. There are many startups out there that offer nice solutions, and also AXA worked together with a startup that had already this matching algorithm in place. That was rather developed for pages like Monster, for usual job applications, for better match applicants to job offerings. But somehow the idea developed, okay, why can't we use that internally? And then the question was rather about, okay, what data do we need from our employees and from the project, such we can do this kind of matching. So, and this is maybe from another point of view quite interesting examples. There are a lot of startups out there, a lot of organizations that offer services, and maybe it's worth thinking about using these services and going with these startups in opposite of developing everything on its own.
Thank you. What role would you assign to the middle management, those often hesitant to change? Could you share some success stories?
Well, this is a quite difficult question. So one of the head of analytics said from the last week's workshops he would change it completely and recruiting new people. But this is quite important. One of the main problems is what came out of the workshop was that these people sit on their jobs usually for quite a long time. And there's very low fluctuation in job rotation on this level. And so it's very hard to push innovations here forward. And maybe this could be a good thing to just make them move around a bit such that they become more open and create also some place for people with a different mindset coming up from the bottom.
Here's a good one. How should universities and business schools integrate data analytics in the curriculum, I assume, apart from employing people like you?
This is a good question. I personally think that business analytics, data science in a couple of years will be a core discipline of most organizations, like controlling, like marketing, like whatsoever. And so people have to be trained for working together with organizations. And I think that all business students need to have some fluency in these domains. They don't have to be data scientists. They don't have to be able to develop models on their own. But if a data scientist come up with something, okay, I used a random forest algorithm with 5-fold cross-validation, and the accuracy of my model is 95%, they must be able to understand what this person is telling me and whether this result is might worth exploring in practice or not. I think this is quite important that they develop some kind of data literacy such that they can work with both colleagues.
Thank you. What are the best practices to get stakeholders, especially clients, to accept the outcome of AI-driven decisions? I imagine that can be tricky sometimes.
Yeah, so usually the easiest thing is that you have some projects that are so compelling in terms of their outcomes that they're like some lighthouse and shine. But it's not always easy to find these projects. And then it's rather something about explaining them, how it works, why it is better, why it is worthwhile changing them, and things like that. And finally, it boils down to the central question: does this algorithm help me as a person to do my job easier, simpler, and more productive? If so, you have a quite big chance that people are going to use that. If it's just more work, they won't use it, and I think it will die.
Mm-hmm. Talking about the analytics translators you mentioned, what is the typical profile or knowledge this professional should have? From what sides do they typically come?
Usually these people rather come from business domains, so they are not data engineers, not data scientists, and so forth. They rather have a deep domain knowledge and some, technical openness, I say, and usually they trained in some courses or on things like Coursera or something to get all the AI and big data knowledge that is required for doing that job. But I think this is usually something that is more easy to learn than getting deep domain expertise that requires 10 or 15 years of doing a specific job, I think. So usually these people come from the business domain.
Mm-hmm. A follow-up question to one of your slides, going to the slide of the data house. Is there a sequence you see on how to best tackle the questions you raised? Would you like to pull up the slide again, or?
No. Well, I think the most crucial questions are two. The first one is rather about the data strategy. What do we want to achieve with analytics? What role does it play in our business? Are we rather like Google or are rather like WMF? So whichever do we have to take? And then I think it's quite important to develop use cases that are compelling, where maybe raise some willingness to pay. I've seen a lot of projects that are really nice, but they are rather like a new and bigger television. So they're nice and they're a good thing, but many people don't see the extra value of using that and buying that. I think both questions are quite important at the beginning. And once you have answered that, you can lay out the rest because there are strong dependencies of that.
Thank you. Could you elaborate a bit more on the change management process, especially when trying to implement a new model?
Well, I think the most important thing is being transparent. So if you speak about things like AI, most people have fear that they are going automated away. And I think this is maybe the biggest roadblock at the beginning. But if you have a clear data strategy and you have answered how we want to create value with that, you can show them how this will help them in their jobs such that they can have a lot of benefits from that. I think this is quite important. And a thing what I also seen in my work is that the field is very diverse. Whereas some people that are quite math savvy, might have good background knowledge in statistics and computer science and machine learning and so on, and other people are completely blank. And you have to convince both of them. And sometimes I've seen the situation that these, opinion leaders that have some knowledge are then taking the lead and telling stuff up the thing because they have a feeling that they know what is going on, and so that there's a lot of dynamics that when are created. I think this is something you have to account for, that you get both parties on board. But the blank ones that have no prior knowledge on that, and the ones that think that they are more sophisticated in the domain, have completely different needs and information requirements regarding the initiative.
Thank you. Maybe one last question coming from a bit of a different angle. Is there some kind of consensus or sentiment about who owns which data?
Well, this is a really tricky question. It depends very, very much on the organizational setting, I guess. Usually the data is primarily owned by the one or by the business unit that creates that. So customer data usually resides with the marketing or retail department. HR data refers to the HR department, and so there's a lot of political debate about what data is shown to whom, and this is quite difficult to solve. And the most advanced organizations I know have rather a complete different policy. They say, okay, apart from the sensitive data, like they have been at university and stuff like that, and other personal data, we try to establish full data access for every employee, or as big as possible, such that there isn't that question about who owns the data, because it's with the company, and everyone who might need something can look at that, whether it's useful or not.
Great. So our time's up. Thank you so much, Ivo. This was very interesting, I thought. If you want to learn more, especially about this topic, join us again tomorrow, same time. We will go a bit deeper into the same topic, also about the understanding of between data scientists and managers, and look a bit more into how these algorithms actually work. And also there's one other webinar coming up on teams and team structures in organizations tomorrow afternoon. And yeah, thank you, Ivo. Thank you for viewing and listening. And if you have any more questions, please reach out to us. I think you have our emails. And have a nice afternoon.
Bye.